So Nick has this question, right? He's questioning about the X. Okay. So now it's very easy. The X is the money that we are giving out, right? So we assume that we have a coupon, and after we give the coupon, we are giving out the money, right? But in realistic, there are some very difficult promotion type. The cost is very difficult to evaluate, right? So if you have some like you are sending gift, right? You are sending some toys, like some loyalty program that you accumulate the points, and if you collect like 10 points, you will get some funny toy, something like 几点送娃娃 things like that, right? And some promotion will have like 来点送啊，什么积点送啊，什么满额送啊 right? So some instrument is like quite complicated, and it's not easy to calculate the cost, right? And that's why you will need to take the course of managerial accounting, right? Because cost accounting is by itself a discipline, right? Right? So this accounting people, they will give you the formula to estimate the X. Okay? So in realistic, if you are talking about a more realistic, more complicated marketing instrument, right? You need to consult your accounting guys. And one of the main job, main task of accounting people is to do the cost accounting, right? So cost accounting is actually a discipline by itself, as I just mentioned. It is actually a department by itself, right? So there's no easy way to answer this question. Yeah.
Well, yeah, now
But
that
you can actually turn that into as long as you can turn that into a formula, you can implement the formula in R, right?
yeah, now that I think about it, a lot of big companies have like programs like this. Like McDonald's will give you like a free toy with a Happy
Right. That's very difficult to calculate the cost, but there are still a way to calculate it, right? And to be a quantitative manager, that is the skill that you need to learn, right?
Yeah, I mean it must make them money because Starbucks does it with points, and like pizza shops say like buy a certain amount of pizzas and you get like free pizza with like their
Right. In that case, it's not so difficult to just put an X there, right? But there will be a formula, isn't it? This cost accounting guys, they will give you a formula to calculate the cost. Otherwise it would not work at all, right? So if you are like Starbucks, you need to do that calculation. You have to, right? So someone will give you the formula for X. Then you just implement it in your program, right? Just as what we are going to do now, right? Now you can see the mathematic equation is kind of like pretty complicated, pretty scary, right? Pretty scary, right? But when you do it in R, it's actually just like 2 lines of code, okay? Okay, as long as you have the M, B, A, and X, of course this is assumption, right? So given M, B, A, X, we can actually calculate the delta P by this expression, right? The dp x MBA is basically just the function that we already implement, right? Okay, so you get this dp x MBA, and you need to do a p minimum with 1 minus b by, okay? Because after the increment, the resultant probability cannot exceed 1, right? Okay, isn't it? Right. So the largest increment on buying probability cannot exceed 1 minus b by, right? And this b dollar sign b by is actually different from customer to customer. You see that? Okay. So this delta P, although in our simplified example, it's DP is a fixed value, right? But after considering the original buying probability, it could differ from people to people, right? So this is the delta P, the actual delta P that apply to every customer, right? So DP is a vector. It is no longer a single value, right? The DP is actually the increment in buying probability for every customer, for all of this, for every one of this 2A531 customer. You get it? So as long as you have DP, you can time it by this. So every customer has its own expected buying amount, right? So the increment on probability times the expected buying amount is actually the increment of buying, the increment of expected revenue, right? And you need to multiply the expected increment of revenue by margin to get the expected increment profit, okay? And that increment of profit need to minus by cost to get your net payoff, right? To get your expected return, expected net return, I should say so, net of cost, right? So the scary mathematical equation can actually be implemented in R in just like 2 lines of code, isn't it? Right. The same thing is that if as for like next question, right? If you have a very complicated formula for x, now you will have something, you will have a function of x, you will have an expression of x here, right? Okay, and that would do the job, right? So by doing programming, you are actually doing the divide and conquer type of things, right? The realistic scenario is very complicated. But when you are doing programming, you actually can divide and conquer, right? Isn't it? Right? So you characterized the cost-effective function in this function, right? And you, in this simple case, we just use x. But in the case that you have a complicated formula for x, you implement another function to represent your x here. Okay. Now after we do this, we will have a vector of expected return, right? Now this vector is actually the expected net return that we apply an instrument of MBA equal to 0.2, 25, 40, and we set the x at 30, right? If we apply this specific instrument to all of our customer, right? If we apply an instrument specified by this parameter, okay, to all of our customer, and the expected return will be calculated and sorted in the vector ER, okay? So if we take a look at the distribution of this ER, what will we see? We'll see that some of the customer will have a positive expected return, right? And actually, some of the customer, they would have like negative expected return, right? And that is the importance of selective marketing, right? Now, today, when we are doing marketing, we no longer do the marketing for the entire population. Okay, we want to be selective, right? So if we apply this instrument to all of the people, actually most of the people would give us negative return. Okay. Only when we apply it to a selective customer would give us a positive payoff. Okay, would give us a positive expected payoff. Do you get the point? Okay. Right. Now, here we do not do the simulation yet, because we just well, you can say that we are doing a single point simulation, right? Because we fix MBA and X, right? So with this fixed MBA and X, we can simulate this single, very, very specific case, and then we can discern the profitable customer from the not profitable customer, right? Isn't it? And that's the way it works. Okay, that's the way it works. Any question up to this point? See, I can actually implement this scary mathematical form into like just 2 lines of code. Okay, and then with this type of calculation, I can actually calculate if I apply this instrument to all of my customer, what would their expected return for each customer, right? So I can see that in a customer by customer basis, which customers are profitable, right? And which customers are not profitable. Okay, so I can make the choice. Okay. Now let's do some exercise. Okay. So based on this, let's go back to RStudio, right? So up to this point, we are in. Up to this point, we are here, right? So actually we will have ER, right? Which is the vector of length 2A531, right? Because every customer you already do the calculation, right? So we have a quick group exercise, right? How many customers should we apply this instrument? So with this let me do it again. With this distribution of expected return, you should apply that instrument to only to those who has a positive expected return, isn't it? Right? So how can we calculate the numbers of the customer with the number of customer with positive expected return? How can we do that? Does anyone do that? Let's do some group exercise, right? Like, how can I do the calculation? You already had the expected return in this vector, right? So how can we count the number of ER that are larger than 0? Anyone? You're basically doing something like this, right? Sorry. Right? Now, if you test this, it will be a vector of true and false, right? And you need to count it, right? Count the number of truths, isn't it? Right? So the number of people out of this 28531, only 7228 customer has a positive expected return, isn't it? You see that? Right? So that's a thing that you need to learn R. You need to do more R practice. You need more practice in R, right? So if you have enough of fluency, you should be able to calculate the expected return. If we apply this instrument to all customers, what will happen? The expected return will be sum of ER, right? Okay? If we apply to all of the customer, the expected return will be negative, right? But if we only apply to those who have positive return, right? The one who have right? This is the expected return of those who has a positive return, right? Because we can use this as the index, right? Okay, so you use the index to select those who are the expected return are larger than 0, right? So and you like do a sum, right? See, that is the difference, right? Okay. Now, if I apply this instrument to all of my customer, I will actually have an expected return of minus like 200,000. Okay. But if I can selectively apply it to some selective population, right? I actually would earn 75.8 thousand. That is the difference between analysis and not analysis, okay? Between selective and non-selective. You get the point? Right. So that is the importance of business analytics. If you do not select, then you have a problem, right? When you are doing promotion. Now, based on this single point simulation, by single point I mean that we basically fix everything, right? We do the simulation by fixing X MBA to a single value, but we don't need to do that, right? We can actually give some flexibility. First of all, we can actually maybe we can fix MBA and change X and see what will happen, right? Okay, so let's see that we are fixing MBA and we simulate X as a sequence, right? So now instead of fixing X in a single value, I can change X, because X, if that is the coupon and you can change the, it's very easy to manipulate. It's very easy to change its face value, right? The only question is now, which face value would give me the optimal result, right? So to answer this question, which could be very complicated math, but in programming you just do the simulation, right? You basically just repeat. You basically just repeat these things on a sequence of X, right? Instead of just doing one X, I can use a S apply, right? To apply the same thing to a sequence of X. So I apply that to a sequence of X starting from 10 to 45 with an increment of 1, right? So it's like 10, 11, 12. up to 45, right? So you can see that I'm doing like the X apply, and that let's actually do that. So so after I let me do it here first. Let's create the data frame first, okay, before gather it. So this is the data frame, right? The simulation, in the simulation, I basically simulate the this is X, right? And this is the number of people with positive. N is the number of person with positive expected return, right? And the E2 is actually, if we apply that instrument only to those who are positive, okay? And the E return is that we are applying the instrument to all of the customer, okay? So these three things are represent, I should have, so E return, N and E return 2, now they represent to like, if we apply this instrument to all of my customer, this is the expected return. Usually it will be very bad, right? Okay, and this is the number of customer with positive expected return, right? And this is the total expected return if I only apply this instrument to those who has positive return. Okay, so so in this code, I basically do this calculation, right? So it's actually I just encapsulate these two lines of code in an S apply, right? And actually this line of code is just to calculate the E return N and also E return 2, right? And I put it into a data frame, right? That's what I do. Okay, so now this is the result of simulation, right? So now you see the optimum number of customer and the corresponding result if you selectively apply this instrument to your customer. Okay, right? So and in this simulation, you actually can find a maximum X, isn't it? Right? If I see this, so the maximum X actually occur when X equal to 34, right? Okay? So if the X is the face value of your coupon, right? You actually should set the face value at $34. And in this setting, you can apply the coupon to 7569 customer and yielding a return of 93549. You follow the logic? Okay? The code is a little bit complicated from here on, but they're just to make the plot, okay? They're just to show you how E return 2 and N varied with X, okay? I mean, the selected code, they are not simulation. They just visualize the result of the situation. To show you how N E return 2 and also E return vary in X. Okay, so you can see that if I apply to all of the customer, this instrument of MBA equal to 0.2, 25, 40 would not generate any profit at all. See, it's always under zero, right? If I apply to all customers, these instruments cannot be used at all, right? But if I has the probability to select, if I can distribute this coupon by mobile app, right? So I can precisely, selectively distribute my coupon, right? Then I can see that when X vary, right? The number of people that I can distribute coupon kind of like increase, right? And so is the corresponding total return, right? Total net return, okay? So I can very easily determine, right? I can very easily determine what is the optimum X that will lead to the maximum expected payoff. Get my point? Right? Now fixing MBA and simulate the X as a sequence, right? I basically can see how the number of customer and how the expected total return vary in X, so that I can see what is the optimum X and what is the, with this optimum X I can determine which customer is profitable, and I can also evaluate if I deploy this instrument to all of this positive customer, what is my expected payoff, right? Which is the maximum expected payoff. Any question up to this point? Okay, so basically this is just one MBA, right? So in the real case, you might have several different marketing instruments, right? So and I'll give you a tool, right? I already give you a tool like this one, right? This 5AEN simulation RMD, right? Let's run it again. So in this simulator, it actually right, do the simulation on two different tools, and you can actually change the the parameters, right, of your marketing instrument, right? So if I have to choose among M1 and M2, right? Now in this case, this is the payoff for all in. I mean, if I apply to all of the customer, right? But this is not what you want to see, right? You want to see the selected type of things. Well, in this case, it's very difficult to determine which one you should use, right? Okay. But when you choose it maybe different. Here you can very obvious see that I should use the pink one, right? Because the pink ones actually have a much higher expected return than the blue one, isn't it? Right? So it depends on. I say that this MBA is kind of tied to the marketing instrument. So you can like treat them as the characteristic of each individual marketing instrument, and as and that MBA, so far we can only do an assumption, but if you have the experience in using some type of instrument, right, in the history, you actually can use a quantitative method try to estimate the MBA. But if you do not have it, you can simply do an assumption, right? But you don't need to fix it at a specific value. Okay, that is the beauty of simulation, right? You don't really need to fix it at a specific value because you can like just change it, right? You make assumption and you write a program, then actually actually you can like write the program first and try to determine the parameter later, right? Isn't it? Okay? So even without the parameter, you can still write the program and write the simulation. And actually, after you have the simulator like this, it's usually easier for you to for you to imagine the range of MBA, right? Okay? You don't know the specific value yet, but at least you know the range, right? You should have some idea based on your marketing domain knowledge, right? You're doing marketing like in 20 years, then you will have some guess about the range of this MBA, right? So, and in this way, you can simulate whatever S curve it is. You get my point? Okay? Now that's the beauty of simulation, right? Um, Now, of course, we can like this is what we mean by multiple instrument, right? Okay, you can like simulate and compare multiple marketing instrument in a single graph, right? Okay, uh, see it's not a very long code, right? It's like it's the code is like not too long. I do not have time to like go through the code line by line, right? But if you have multiple instrument, you will need to define this instrument, kind of like using a vector, right? Using a vector. So the first instrument has MBA equal to 0.2, 25, 40. And second is 0.25, 30, 40. And the third one is 0.15, 15, 30, right? Things like that. You can define it in a data frame. You can also define it like in vector like this one. Okay? Whatever is convenient for you, right? So after you like define the instrument, you can actually like draw their S curve, right? Together. This is the code to draw their S curve together in a single graph. Okay, I know that you might not have the capability to do that yet, right? So, but if you continue to write our program, right? Many of our uh, business in business school, most of our students do not have programming capability, right? In business school, But some of our students, if they take my course in the first year of their MBA, right, and they keep using our programming, right, by the way they are graduate, like they can like implement a program by this, but you need to write program after this course, right? It's not enough. That if you stop here, then yeah, the most valuable things that you have learned would kind of like get lost, right? So so I would encourage you to like use the business analytic technique in whatever discipline you learn, right? Okay. Today we are talking about marketing, right? But you can apply the same thing to accounting, to operation, to supply chain management, to strategic management, right? Even to human resource management, right? Nowadays you have more and more behavioral data, right? In each of this discipline, right? So if you keep using the R programming, apply it to whatever discipline you are going to learn in your MBA starting, right? You have better and better capability in using R, right? And when you actually using this R programming in something that you are specialized. This MBA, we are learning MBA. You need to learn everything, right? But I believe that every one of you have some specialty, right? Some specialize in finance, some specialize in like marketing, some specialize in supply chain operation, some specialize in retailing marketing. So the same thing can be applied to every discipline, and if you keep using this R program, you get stronger and stronger, and well, hopefully, right, by the end of your MBA starting in NSYS, you can have some capability. As I told you that like not every one of my students in my class can go to that point, right? But they are like 25, maybe 30% of the students, right? After taking my course, they keep using it, right? And he use it in whatever discipline that he specialized. And if you do that, you will run into problem, right? I mean, like 2 months after this course, like if you are taking a course like operation management, supply chain management, and you have a lot of data, right? And if you want to do it in R and you don't know what to do, just come to me, right? I'm not closing my consultancy after this course, right? You know my office, right? Okay, just come to me. Bring your data, bring your problem to me, right? I can do whatever I can to help you use the data to make decision. Use the data to make decision. That's the point of business analytic, and that is the key objective that we want to learn in this course. Okay. Okay. Now, see, actually, this is just this is the same thing as this one, but it has like 4 instruments plotting together, right? Okay. So, so after you do the simulation, you can see that after the simulation, let me close it. So if you run to this point, No, it should be this one. Go back to the file simulation RMD. And then we run, maybe I should like turn on the okay, after, let's go to this channel, right? The optimal strength for each instrument, okay? So suppose that you have 4 instruments, right? Defined it by this 4 set of MBA combination, right? Define 4 instruments in this 4 MBA, okay? And after the simulation, we want to see the optimum strength for each instrument, right? So it's actually very easy. You just 1 lines of code. Now you can see that, right? I is the instrument ID, right? And X is the optimum X, okay? And these 3 things are the same, right? This is the expected return. If we apply to all customers, then you can see that they are all negative, okay? And this thing is the number of customers that have positive expected return. And this is the sum of expected return if we only apply to those positive customers, right? So you can see that 4 instrument has 4 different cutoff point, and they have 4 different expected return, right? And in order to get that, if you have enough of fluency in R, it's just like 1 line of program. See that? It's just 1 line of program. You can like draw out the most important information that you want to see, right? In a single line of program, right? Because I'm like, I have my result of simulation in DF, right? And I group them by instrument, okay? And then after group by instrument, I choose the top one that had the largest, for each instrument, I choose the raker that has the largest expected return selective, okay? So you can see that in this 1 line of code, I actually already have the simulation result that I want, right? Okay. So you can see that the code is kind of lengthy, but most of the code is just to make the plot, okay? So if you only want to see the result, well, the most important result to you is just this, okay? And the code to run the simulation is just like less than 10 lines of code. You can do a simulation for 4 different instruments. Like actually the same code can run to like 10 different instruments if you like, right? It's not difficult at all. And then you can use this to see your optimum result, okay? You get my point? Okay, so that's why we want to learn programming, right? With programming, we can let's go back to this slide. With programming, we can make assumption, right? Now, even though that we do not know the MBA, we can still write the program, okay? You can write the program first before you determine the MBA, right? Okay? If you do not have a very good certainty about the MBA, you don't need to, right? You don't need to have a certain MBA, right? you can actually allow some range, right, of possibility of this MBA, and you write the program first, okay? Then after you write a program, you can adjust the MBA, right? And for each MBA, you can choose the maximum X, right? And after you do that, you can actually select the instrument, choose your subject customer, and actually estimate the cost and return for each of the instrument, right? And because you are not certain about the MBA yet, okay, so so you basically can use this like interactive, right? You basically can use this interactive simulation tool to see how the optimum solution and the maximum return would change when the MBA is changed, right? Okay, okay, that's the core. That's the objective. I mean, that's the objective, the final objective of business analytics, right? So next week I would like you to like use this as the use this. As I say, I cannot like teach you the detailed programming for modeling, for optimization, for everything. But actually nowadays, most of this complicated algorithm has already been encapsulated in packages. Okay, as long as you know the package, right? Okay, you just fit in the data, and the package will do the modeling, do the exploration, do the prediction, and even do the optimization for you. Okay, so what you need to learn is that you need to have a systematic, a holistic view like this, right? See, this business analytic nowadays is a matter of using tool. Okay, let me say it again. Business analytics nowadays is a matter of using tools. Okay, so the R language is kind of like this conveying belt that connect the tool together. Okay, so that you can like manipulate the data. So you can use the tool, right? Because each tool, before using each tool, you need to know the format of its input, right? Okay, so you manipulate the data so that you can use this tool, and you can connect this tool together to help you do this business tasks, right? And that is business analytics. I want you to use this slide. I want you to use these slides and use the Tafond case that we have went through together, right? To make a like 6 to 8 minutes presentation next week. Okay? Do you have any question, problem? That's for next week. So we do not have like you don't need to do the personal assignment this week. Okay? Simply like I know that this week some of you might still have to do the final examination, right? If you would like to do your team presentation during the weekend, during the upcoming weekend, I will be in my office, right? So you are welcome to come to my office and discuss with me, okay? And don't forget that we are not talking about like doing modeling or doing something, right? We are talking about, I think that the most important thing for you is to get a holistic, get a systematic idea about what is a complete business analytic process. That is my objective, and that is the most important thing. Okay? Problem or comment? So you don't need to do the actually you don't need to do the personal assignment here, but actually doing this personal assignment would help you a lot when you are preparing this when you are preparing your presentation next week, because in this week's personal assignment, if you look into the notebook, I changed the situation a little bit, right? In this simulation, I'm actually I'm simulating 4 different kind of marketing instrument, right? This MBA represent 4 different marketing instrument, okay? But actually it could be the same instrument in 4 different age groups, right? I mean that MBA could vary in different age groups, right? For example, if you are sending some toy, right? Some toy would be very attractive to youngster, but right? If you are sending some gift, that gift could be more attractive to elderly, right? So rather than the parameter would change a closed instrument, that MBA actually can change a closed age group, right? So I'm telling you that if you want to do this assignment, you can actually you can use the same code, right? Try to modify the code, right? And now we are no longer applying the MBA to the entire population, okay? Each of these instruments actually apply to age group, okay? So try to do this exercise and try to find the NXN, expected return selective, okay? And this is basically this part, right? Okay. Okay. So if you want to use the Tafang to fill up this portion, prediction, assumption, simulation, optimization, right? You actually can use the group assignment this week. Try to enrich your presentation next week, okay? Okay, so it's 12 o'clock already, so I will stop here. So anyone who has question can stay, and today's course will end it here, okay? So next week I will start with your presentation, and then we will wrap up the course, okay?